Good afternoon. As you noticed, our problem changed slightly because the other one was not grouping nicely. It required some procedures more than what we already know. It required rational zero test, finding zero procedure. It's a long procedure. We skipped 3.4, section 3.1. That's why we couldn't figure it out. So instead, I switched the question into a nicer one, and your homework set is also changed. So how do we do this problem again? First step, now we have to do step one, which we skipped in the earlier question. We need to have a zero on the right side. And do you have a zero already on the right side of the inequality? No, we need to take care of 18 and 20. How do we do that? Subtract. All right. Subtract these. Okay? From both sides. Okay, I subtract these and we have a nice, perfect zero on the right side. How about the left side? Are there any like terms here? T cubed, squared, t and 20? No? They all line up next to each other. We have 4 terms on the left and nothing but 0 on the right. Step 1 over. We just got 0 on the right. Next, step 2. Just ignore this inequality and treat this like an equation and solve it, please. Just like you're solving an equation. And one of the basic methods in solving an equation is factoring it. Unless it's only t and a number, you need to factor things to solve, okay? If you have especially square and cube, yeah, definitely we need to factor. And what a coincidence, a 4th term, and one of the famous factoring methods require exactly 4 terms. It's called grouping, 4-term grouping method. We are going to factor these 2 by 2. And what is common in the first 2? Anything common? T squared. Only t squared? Yep, nothing else common between t and 5. So this t, 2t plus 5. Okay, how about the other group? 8t and 20.
Minus 4.
4, not only 4, but you guys also mentioned it's minus 4. Negatives are also common. So why don't we call not only 4, minus 4 together out. And what is left? If I borrow 4 and minus from 8, it's only 2t. If you want to take minus 4 and minus 4 out, 20 is just 5. The plus sign. Oh, what a coincidence. It's now matching. The other day it wasn't matching, now it's matching. Oh, this is an equal sign now. I just momentarily, I imagine this as an equal sign. I'm solving it, okay? But keep the original one on side, so you're gonna go back to this. This is original. This is my new converted one, okay? So these are matching, and whenever you have a matching parentheses, you borrow them, one of them here, and factor. And I recruit each parenthesis, 2t plus 5 from each term. These are kind of gone. What's left is what? T squared and negative 4. Alright, it looks like we factored it. Some people may be happy and say, oh, so let's stop here and start solving. It's possible you can solve at this moment, but it's better to do one more move. What do you think we can do extra?
T plus 2, t minus 2.
Right, this is still a square. Whenever you have still a square in a parenthesis, that means you can maybe break it. And this is one of the common factoring forms, especially if you have squares around each term and a minus difference between them. It factors as 4 is 2 squared. It factors once with a plus, once with a minus. Okay? And the first one is already the same. Now this is the complete factorization. You can't break either piece anymore. That's it, stop, and start solving. You need to set each and every part into 0. Alright, this is 0. T plus 2 is 0. And t minus 2 is 0. Alright, what do you get if you solve t here? Anyone? Perfect. How about the other one?
-2.
Great. And the last one?
+2.
Positive 2. We have 3 solutions to new equation, set it into 0, but that's not the real one we are working on. Remember, we are working in inequality. Let's see what we are going to do next. Okay, we are going to determine the intervals. This question requires this expression to be, okay? So for this, I'm doing number 3. In my way, my explanation is a lot of wording here, but this is what you're going to do in number 3. We are going to make a table or chart, okay? This is your chart. It's actually a real line. Remember, you've been doing this, taking intervals out of it, holes, brackets, parentheses, that kind of thing. Well, there are 3 boundary points on this line. What is boundary points? These solutions you obtained are kinda borderlines, borders, or kinda evolution points. Whenever your values, function values, the expression values pass beyond this value, the expression tend to change its sign. So these are boundary points for sign change. Before or after these points, your expression, that cubic equation here, can be either negative or positive. This is like neutral line between 2 zones, negative zone and positive zone. Okay? So first thing you're going to do is carry these border lines, border points, boundary points into the graph from, of course, smallest to biggest number. Which one is smallest? -2. So I'm going to put -2. No, it's not the smallest, -2. There's a smaller one. This is -2.5. So -5/2 is the furthest left. -2 is a little bit to the right of it. Well, +2 is, if this is 0, probably somewhere here. Okay. So how did I determine these boundary points? They actually happen in 2 different occasions. First, you set the equation into 0 and see what values you get. Actually, there is one more occasion it can happen. The numbers that make this function undefined are also border points or boundary points. But this is a cubic polynomial. Are there any values you insert in t and can make it undefined? Can you find such a value? No. So this works with every number. That's why I skipped that second locations. Those boundary points can be found. Okay? So there are actually 2 searches you need to make. Search 1, which I already did in detail. The second search, I did it verbally. You are going to look at the numbers that makes the function undefined. And those functions are usually ratios or square roots. You need to check ratios or square roots for that. This is safe and secure, it's fine. Only 3 boundary values. Okay, now as I promised, these are kind of danger zones. Your function may flip the positive to negative, negative to positive there. How can I make sure? How can I make sure what the sign is between minus 2.5 and minus 2? What is the sign between minus 2 and 2? Once you pass this boundary point, I'm 100% sure the function stays the same sign. If I figure this out, if maybe positive, it's going to stay positive everywhere until the next moment. All I need to do is discover one sample value here and make sure, oh, this guy is positive everywhere between minus 2 and 2. How can I test this out? How can I discover the sign? Yeah, any ideas? I need to figure out, okay, here's your function. Take the original expression right here, 2t cubed and plus 5t squared minus 8t minus 20. I just need to check when I lower than minus 5 over 2 here, whether this thing is positive and negative. How can I check that? Or when I'm between minus 5 over 2 and minus 2, I want to check this is positive or negative. How can I test? Yeah. Take one sampling value from each region, such as less than minus 5 over 2. What's the best value you can pick? This is again like 2.5. So just take the whole number right before it, which is negative 3. Okay? So enter negative 3 and compute. So this is just testing. Take some sampling, x or t in this case. Alright, and you said negative 3 and substitute in t. And you don't have to compute all the way. You just need to convince that whether this is negative or positive. What do you think the answer will be? I just need to know whether it's negative or positive. Well, this is a negative big number. When you cube 3 times negative 27 times 2 is negative 54. This is positive 45. Positive 24, negative 20. What do they add up to? Anyone? Alright, negative 54. Positive 45. This time still negatives are winning. This time positive 24 and minus 20, you have 4, 45, 49, and still negative 54 beats it. It's minus 5, I believe. It's a negative number. You don't have to be 100% correct with the digit. As long as you get the sign correct, you're done. I just tested and value here, test negative 3, and I just discovered it's all negative on this side. Okay? Now let's test a value between these two. Oh, this is nasty. What value you want to choose t to be? Between 2.5 and 2. What is the best value? There is no best value. Pick one. 2.25. What about 2.1? Okay, 225 is fine. I mean, you're gonna punch in 3 digits here, 225 in your calculator. If you want to type in just 2.2 is fine. 2.1 is fine. 2.4. I definitely need your help. Plug in here 225 and tell me the result. Negative. We're testing negative though, it's negative. Positive or negative? Come on, anyone? Take out your calculators, come on. It's positive. Well, I kind of was expecting positive. Usually between each region, the sign flips on the border boundary point. So I was expecting positive, but I'm not double checking, but somebody double check. Because sometimes they don't flip. But it happens rarely. Okay, between -2 and 2, what is the best value? There is one best. Between -2 and 2. 0, of course. 0, when you make t 0, it all disappears. So it's 0, this guy, 0, 0 is -20. Right? 0, 0, 0, and only -20. It's negative. Were you expecting negative? Yeah. So I expect to switch signs. After 2, what is the best one? 3? Or if you like working with tens, some people like 10. It's easy to cube 10, but 3 is fine because we already have 3. You know how to cube 3, right? So get this. I think this is positive because such big numbers here. Big positive numbers, small positive numbers. I'm guessing it's positive. Double check though. Okay? Alright. We're almost done. It's the decision making time. Now, ask this question. Why did we build this thing? How is this chart related to what is asked in this question? Did you see why? Do you see why I did that chart? I want you to focus on this one. I'm going to clean intermediate work. Take a look at this equation. What does it say? Especially this inequality. How do you guys translate this inequality? What does this mean? Less than. Okay, now I want you to translate not only this, these two together. If you see something less than 0, what is the another way to say this? Negative. Negative. Less than 0 means negative. And what's the short symbol for negative? How do you make negative sign? So we are looking for where this thing becomes minus, right? Minus. And look what we found. A chart tells us where this thing becomes pluses, where else it becomes minuses. All we need to do is take your color pen and mark the intervals, or between what two numbers it becomes minuses. Look, question is asking me, where is this thing negative? And I'm telling them, here and there. That's it. All we need to do is write up our solution in proper way. What is the proper way? Interval notation. This is still graph notation. We need to turn it into interval. So can I clean this part? We don't need this work anymore unless there's a mistake. There is no, right? Well, we'll see that in a moment anyways. Okay, how do you write up this? How do you turn that part into an interval? Yes. What is the starting value? We don't have anything, so it's negative infinity. And infinities are always used with parentheses, no brainer. Okay, how about this one? The end, right end is, where do you stop? Okay. Don't write anything yet. Okay, there is another one coming. If there are two disjoint, they are separate intervals, we are going to use union symbol among them. And the second interval, starting value is -2, and ending value is 2. Alright, here is the question. I said these are the border lines, border, or neutral values, or boundary points. These guys are neutral. We don't know they belong to negative or positive side, okay? We don't know if this one belongs to negative or positive. So we really need to test them and decide whether any of these numbers are included or excluded. So you need to decide any number showing up, not infinity, infinities are safe. For any number side, you need to decide whether they are included or not, okay? And for this, take this number in and substitute here and see what it makes. What is -5/2 gonna make? What do you think it's gonna make? 0, because this guy was a 0 of the polynomial. We've solved this 0 and found -5/2. We set it into 0 and found this. So my -5/2 is gonna make this thing 0. So should we include it in the solution? Should we? No. They say strictly negative. But some questions will have this extra piece. If you have this extra piece, then you will include -5/2. Now we are safe. We don't have to. So this end stays parentheses. Okay, how about that end? -2. Same reasoning. What was -2? It was a 0 maker. So when I substitute it here, it's going to make it 0. And we do not like equal signs. Sorry. You are staying parentheses. How about 2? 2 as well, stay in parentheses, because 2 is a 0, it's going to make it 0. Pretty much, if there is a strict inequality, no equal sign, all ends are parentheses. Except sometimes there are some undefined values. If there exists some undefined values, you need to watch for them. You need to test them. Actually, they stay undefined as well. But if this is equal, and people tend to take undefined values also as a solution set, so we're going to watch for them. It's coming up in the next questions, okay? So far, so good. Any questions? All turned out to be excluded, and this is our final solution. These are the regions we are supposed to type in. Write the solution interval notation, yeah. Oh, thank you. All right. Ready for the next question? Anyway, any questions? Any part you get it? You need more details? It has several parts. But it's such a basic equation. Look at this. And this part, even part 1, this question does not belong to this section, trust me, because you have equal sign. This section is about inequalities. This is kind of a review of past knowledge. How do you guys solve this? It says solve, right? Solve each equation. Now we need to solve. What is our very first solving method all the time? Factor, 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 all the time. Unless you have a single A, we factor. All right, I think everybody knows directly how this is factoring, right? Do you? This is single, So you only need to do is figure out two numbers here, multiplying into 9 and adding to -6. So I would like first distribute a's and guess two numbers. What two numbers are they? -3 and -3. Perfect. And we solve. Now, since each piece is the same, you just solve it once. A equals 3 is the solution. How easy is that? Alright, I'm wondering the next part.
It's a different problem.
Ah, how would you do that? Okay, so can you do this on top of your head? It's 4 this time, right? Yeah, it's 4. Alright, the next one, I'm gonna take this and solve it. A squared. Oh, what's the change? Do you see any change? A slight change in the equation. This is now less than 0. Alright, part 2. You have a squared minus 8a plus 16 less than 0. Okay, there are two ways you can solve this question. I will first do the ordinary way I did in question 1. What is it? You first treat this as a 0, set it into 0, right? And it turns into this. And then solve. Well, haven't we solved it already? So I'm cheating from the left side. Factor and solve, you get a equals 4. This is your boundary point. Boundary point on the chart you're supposed to make. So let's make that chart. Here is the chart. And where is the boundary point? If this is the middle, it's somewhere here. Now, take a value from the left side and take a value from the right side. Tell me pluses and minuses. On the left, which value would you take? Best value is 0. 0, 0, 16. Is it negative? No, positive. So on this side is positive. I tested 0 quickly. Not yet. I'm testing in A, right? Okay. Alright, how about the next value? What value you want to test here? Test 5, 10, 100. Anything more than 4 is good. When I put 5, 25, minus 40, plus 16, total is 1. Positive 1. Oh my god, this is strange. Because mostly during the exam stress, you guys flip signs. You expect here minuses and you put a minus here. This is surprising. It turned out everywhere this thing is positive. Entire real life. No matter where you pick up, this thing is positive. How did that happen? I don't know. Well, what is the question asking? Somebody translate this, please. What does this translate into? Negative. They want where this thing turns minus. Tell me where it turns minus. Never. Never. The solution set is empty. Solution of this is empty. It never happens. Why? Now the second method. We just did the ordinary method and we got the answer by regular solution method. What is the other way? Now when you guys factor this, don't you get same two factors repeated? If you have a repeated factor, how do you write it shortly? Isn't it a square? This thing is a square of a minus 4. And they are asking me that. I'm looking for a value. You need to find out all numbers. You're going to take 4 off and square it, and it's going to be still negative. When you square numbers, no matter what value it is, can it ever be negative? Can it ever be negative? No. We have seen it the hard way. We have proven it never becomes negative. You could have actually answered this question in 2 seconds if you observe this. This is just a side way, okay? Alright? So I see that this is positive all the time, never becomes negative, no solution, or empty set is the answer here. How do we say empty here? Okay? Next. This is interesting. Do you see the difference? They have just put equality under this thing. They are saying, okay, it never becomes zero, I buy it, but when does it become equal? Can it become equal? And part 3 says, yeah, I know it never becomes zero. So this says, this question has two parts now. One is strictly less. The other one is equal. This means less than or equal to. I know this has no solution already in part 2. Can this be 0? Are there any values that makes this 0? Yes, 4 is the only one. We already experienced that in part 1. Well, if you want to do this ordinary way, this is what you're supposed to do. When you do this, add equal sign, you say there is no place making it less than 0, but this we said neutral. Undecided. You haven't decided what's going on at 4. Maybe this guy makes this thing through. So you check everything after, everything before, but we haven't checked 4. Right? We haven't. We didn't touch 4. Check after, before, not 4. All you need to do is enter 4, see if it makes it 0. Does it make it 0? Yes, it does. So we have a solution if you put an extra piece, the equal sign. We have this thing 4. Alright, this is kind of straightforward for those who observed it already. We flipped the direction of less than to greater than. We are looking for, what does this say? We are looking for where this thing is positive. Any answers? Hold on. Let me write it first. I'm looking for where this thing is positive. You said, Austin? Where, you say this? Why? I was hoping to check this and see on the left we are good, on the right we are good, so it's everywhere. Everywhere. Why did you skip? He skipped 4.
Plus 4, 0.
Because at 4 we have equal to 0. 4 was neutral. You can't put it in the positive side yet. You need to check. When I check 4, it's making 0. It's not making positive. 0 is not positive, right? So it's only making 0, so 4 should be excluded in our answer. So again, this is the situation you have. You have a hole in your solution. 4 is excluded. You take the left side, negative infinity to 4. And you take the right side, which is 4 to infinity, right? Because of this hole, you have 2 split intervals. Okay? Make sense? This question was kind of a reasoning question. It wasn't too algebraic hard work, you know?
It's negative.
The first one, right?
Yeah.
Thank you. Alright, we're good. Oh, we have a part 5. Okay, we have a part 5. The only difference is now you're including 0. What is your answer? everybody is good, right? We want 0 as well. Okay. Now, a new world. A world of fractions. Now, you know what happens when you have fractions, right? Denominators happen. And denominators are kind of fragile. They are sensitive to some numbers. You need to avoid those denominators becoming what? 0. So, but steps are the same. Only difference is when you were only searching where this entire function becomes 0, now you need to also search what values of x makes this thing undefined as well. So you may have more boundary values.
So I can be the same as the question on the homework.
What homework question? Oh yeah, thanks for reminding. Is it the same? No, thanks. 1 minus x, x plus 5, 2. Oh, it's almost the same. This is 1, right? Alright, what is step 1? We need to get right side 0. Do you have a 0 on the right side? Do you? No? We need to get this guy out of here. How? By subtracting 2 from both sides. So this is what you have now. Okay. So far so good? Next. Alright. I give you this optional. This is an option. Some people like to combine these two fraction and whole numbers by setting 1 and multiplying both sides with this numerator so that you can get common numerator and combine. So you can have a one big chunk of fraction rather than a fraction and a whole number. I kind of like it, but it's optional. You can still keep this separate and proceed accordingly. I want to combine them, okay? All right? So how do you meet these two denominators, 1 and x plus 5? This is only 1. All you need to do is multiply this guy, both sides, top and bottom, with x plus 5. It's just going to look nicer when everything combines, okay? Now, I can combine these two fractions because they share the same denominator. And what is top? 1 minus x. And this comes next to these guys now, minus 2 times x, right? And we have a 5 next to x. Mistake. There is a mistake. Where?
Minus 2x minus 10. And multiply the minus 2 times 5.
I think Austin said positive 10. Did you say positive 10? Minus 10? Okay, yeah. We need to take these two, combine, distribute to each and every term in this block, x and 5 block. So it's not just minus 2x, it's minus 2 plus 5, which is minus 10. That's an enormous mistake. It's going to mess up everything if you ignore that. Now everything is fine. Let's combine like terms on anything like. These are like, right? And 1 and 10 are like. So can we combine them? So that makes, I like x's first, so I will take care of these first. Minus 3x. And 1 and minus 10 makes negative 9, right? This is positive 1, negative 10, negative 9. X plus 5 greater than 0. Okay? Happy? Now, at this stage, you look for some factoring. Are there any kind of factoring going on here?
You could do 3 out.
Yes, we can pull a 3 out, okay? So I'm going to pull that 3 out, and then, what? Negative 3, yes, negative 3. I'm pulling negative 3 out, and getting x plus 3 up there only. Okay, now, finally, we're done with step 1. Alright, again, step 1, although it doesn't mention it, I put this extra step and say, make 1 fraction on the right side. Fraction on left. Combine things and make, I want to see only everything on the top and bottom of fraction, that's it. It's going to make our life easier, okay? And factor. Factor as well. We're done with step 1. We're going to search for those boundary points. First, search 1. Set this guy into 0 and dig up all x values making it 0. And trust me, it's quite easy. So in step 2, search 1. Setting this into 0 and solving it. Look, it may be intimidating when you have a fraction, this ugly denominator, but fractions are so beautiful when they are set into 0. They are really nice. They are really tame. How? We need to get rid of that denominator, right? So take that denominator and multiply both sides with that. And look what happens. This is the beta of 0. When you multiply, these two cancel, of course. When you multiply 0 by no matter what, it turns things into 0. Okay? 0. Distribute if you wish. 0. Okay? Next. What is next? Remember, we are solving for x. You need to get x alone. Minus 3 must go. Positive 3 must go. So what do I do next? Divide by negative 3. Oh, beta of 0 surfaces again. What happens if you divide 0 by a number? 0. And okay, do you want to know the shortcut? I did a lot of work here. Do you want to see? Do you want to know? Are you really curious? Or I can do the next part. Are you curious? Okay. Here is what. Once you factor this, only take the pieces under each parenthesis, like we have only x plus 3 here, right? And set them into 0, that's it. You can ignore what's in the bottom, you can ignore constant numbers, only take the variable parentheses or factors, variable factors. If you have, for example, x minus 5, 2x plus 1, etc., etc., only take each and every and set it into 0. That's what you're going to get here, okay? That's shortcut if you're in a rush. But technically, I'd rather do that way. So we have only one boundary value, so we can search for pluses and minuses. Agree? Are we done? We have only one boundary value, right? No. We need to also find some values that makes this fraction undefined. They can be boundary as well. Are there any values making this thing undefined?
Negative 5.
-5. Yep, that's the second part of the search. Boundary value search continues by setting the denominator into 0. That denominator gives us -5, another boundary value. So it's -5 and -3. Okay? I want to put a reminder, so in case I forget, this is the value make undefined. This circle means this is the value that makes the function 0. So I know the difference between these two boundary values. This is the one bad guy, this is the one making 0. Okay. Alright, let's test. You need to take a table and start testing. We need to test only 3 values. One from left, one from middle, one from right. Alright, x, f of x. What x value you want to test from all the way left?
Negative 6.
Okay. Where? Where do you test? I recommend, we want to take it this one. Now I recommend, okay, this is our main equation. I recommend working with this factored form. It's easier with factored form. So use this guy for determining your final solution and determining this table. So I'm going to put -6 everywhere. Look what I'm making. What did I do? I only checked their signs. This is negative, that's negative. I don't care what exactly this number is. All I need is whether this is negative or positive. When I put -6 here, it's negative. When -6 makes this negative, what happens if you multiply negative by negative on the top? Positive. When I divide by negative, it becomes all negative. I don't need to know the numbers. All I need is signs. I'm working with signs. So this thing is negative. Use a different color maybe. Okay. Or if you really want to work with numbers, yeah, take a calculator, multiply these two numbers and divide by the third one, you'll get the same thing, right? Alright, test something from the middle. -4. You have only one shot, right? There is no other option. -4. We're testing. Test. -4. And this time this is negative. That's 1. On the bottom is positive. The result is positive. Why? Negative and negative multiplies to positive. Divide by positive, it's positive. Were you expecting that? Yeah, they usually full of signs. But not guaranteed. Don't trust that. The last one, pick something after -3. The best choice? 0 is best. 0, test 0. I think we're going to get negatives here. How? 0, -3. When I plug in 0, it's positive. Positive. Negative, positive makes negative. Divide by positive, still negative. What is this question asking? Which region is it asking? Somebody translate this. Bigger than 0, but what sign is that?
Positive.
They are looking for locations 0 or plus. You're either going to locate pluses or zeros combined, okay? So where are the pluses? There you go. Are you ready to write up your solution? Alright, interval between -5 and -3. We're done. Agree?
You don't include -5.
Yeah. Who gave me the right to include? These are neutral. Neutral, neutral. how do I know they satisfy my equation? First off, undefined value can never be included because it makes your function undefined. Test. Plug in -5 here, you can't compute it. Definitely this is a no. You can't include undefined value. One is a circle. No, right. How about the other one? Shall we count this one in? Yes, because it says 0, of course it's gonna make this thing 0, right? So it's -5 -3. All right, there is one more question left, and it's kinda similar. We can finish quickly that next time on Monday, and we'll start our new chapter. We're going into a whole new chapter next time, okay?
I only have 3 more.